Hey there everybody, it's Mr. Verzat. Today we're going to look into perspective and we're going to break it down into its most basic components before even learning how to build anything in 3D. So what I just want to talk about is the horizon line, the vanishing point, all the different things that come together in order to make this illusion work on paper. So let's get started. Welcome everybody. Today we're going to look at the linear perspective, the illusion of 3D. Now I say illusion because we are creating an illusion on paper. We're fooling the viewer's brain into thinking that they're seeing something that's 3D. Now in order to do this on a 2D surface, we need to follow several rules in how to do this. Just like any magic trick, there are steps to it. So let's break it down into its most base components. Let's start with the horizon line. The horizon is actually the eye level of the viewer, or the eye level of the camera when a photograph was taken. It's the elevation of where the camera is positioned within a shot. Now this is the horizon line in this image. And as you can see, the camera was elevated about at just a little past the height of these countertops. So let's look at this in detail. I've got two shots of the same interior. Both are rather poor quality, but here is where the elevation of camera was, probably about 5'8" or so, based on how tall this refrigerator is here in the left. But you can see that the angles above this horizon line are going down. Like we can't see on top of this fridge, we cannot see on top of this cupboard, but things that are below the horizon line are going up, and we can see the top of the countertops over here. Long story short, whatever is above the horizon line, we cannot see the top of it because it's taller than us, and whatever is below the horizon line, we see the top of it because it is shorter than us and we are taller than it. Now this is the exact same room, just better quality photo. This is as if you were sitting on the ground. Notice again how the angles change. Things above the horizon start to point downward, and things below the horizon start to point upward. We can no longer see the tops of these counters or the tops of the table because camera is now placed below them in height. The elevation of the viewer is now shorter. So ultimately, horizon controls how forms are distorted, how their angles are controlled. Now where you put your horizon line on the paper also matters a lot. If you put your horizon line up near the top of your page, we call that a bird's eye view. And if your horizon line is placed down low, we call that a bug's eye view or a worm's eye view. Because mostly everything on the page is above the horizon line and taller than us, so we'll be looking up at it. So for example, we can see the dog's belly, but not the top of his back. Here's a graphic demonstrating how horizon works with your line of sight if you were the viewer in that 3D space. So here are you, here's your line of sight looking at something, and that is your horizon line. Here's the ground, and this line here represents your height in the world. Let's put some objects in this world. The horizon line doesn't actually exist in the world that you're drawing. All it is a scaffold. It's kind of a guide to help you know where to arrange things. So by looking here, this object is taller than the viewer, which is why it is past the horizon line, and this object is lower than the viewer, shorter, which is why it is below the horizon line. Let's take a look and see what this would look like from this person's first-person perspective. This is what the figure in the picture earlier sees. And sure enough, here's where the horizon intersects this tall form. We cannot see the top of it. And likewise, this shorter form, here is where it is below, and we do see the top of it. Here's some characteristics again of the horizon line. If you want to pause this or take a screenshot for your notes, feel free. It's the height of the camera or the viewer. It is an imaginary scaffold that is used to build stuff in the shot because you need to know if that thing is below or above the horizon. If you have several objects of the same size, they will always be intersected by the horizon line, no matter how far away or how up close to the viewer they are. So this guy, the camera is about up to his ribs. The horizon is going to intersect his rib cage even when he's way off in the distance because camera determines the height of horizon line. And this fella is still the same exact height as this fella. It's a distortion effect. I want to look at the term parallel, and what that is when you've got two lines, or two or more lines, that run side by side next to each other, and they never touch. That they remain at the same distance apart for eternity. And it's pretty straightforward. If you have a room and you look around and you've got a wall on your left and a wall on your right, those walls are parallel, if it's a box. If not, then you've got a pretty interesting room. So let's take a look at this oven structure here. Let's try to find some parallel lines. We can look at this handle, and let's see if there's any lines that are parallel with this. Well, there's this fella right here. There's this face, or this surface, that's parallel. The bottom is parallel. Likewise, if we go up and down, this edge is parallel with this edge. All right? So this is mostly common sense. When you look at a picture, try to imagine, realistically, where the edges are located that are parallel. Even if they're in 3D, the same principle applies. So this edge is parallel to this one, this side is parallel to this one, and so on. Now the difference is, though, is that these lines that are slanted, now they recede off into the distance. For example, this is closer to us than this. And we know that because it's at an angle and it is receding. That brings me to the key in this illusion, and that is the term called convergence. Convergence is when two or more parallel lines meet at a single point. Now remember, the definition of parallel is that they do not meet, but here is why they do in perspective. It's a camera distortion effect. Things that get further away from us and things that run side by side start to narrow and converge at a single point. That convergence is what creates the illusion of distance, and you'll hear me refer to the word convergence many times. So looking at these beams, for example, though in the photograph they appear to converge, in real life they are just side by side and parallel. Again, the convergence effect is an illusion. That's the basis for the entire illusion. So let's try to extract some convergence out of this photo that we've seen before. Let's try to find some convergence lines. Feel free to pause the video, do it yourself, and then hit play, and we'll look at them from there. Here's just a selection of a few. The tops of the counters, even the pattern and arrangement of these knobs on the oven are side by side, and that arrangement is parallel to, like, say, the ground. This all creates convergence. But again, being parallel does not mean that you're going to converge. These lines are parallel. You must be receding far away from camera in order to get convergence. Now this leads me to another tool. The point where they converge is called a vanishing point. That's where all those receding parallel lines meet. You'll hear me abbreviate it as VP, vanishing point. At this beginner level, the VP always sits on the horizon line. It does not exist anywhere else in the shot. All right, so let's get a little more in depth as to this whole receding line kind of a thing. There's a term for it. If you've taken geometry, then lines that recede off into the distance that's called a z-axis, and that's a plane that goes either far away from or coming towards camera. Now there's another axis, and that's called the x-axis. You can see it with these poorly chosen colors of green here. And an x-axis is an axis that moves left to right and does not converge. For example, the edge of this floor, or any one of these railing lines, the stairs, or this giant beam up here. If you know that there's an x-axis, there's also a y-axis, and that is a set of lines, again, poorly chosen green, that moves up and down, north and south. And they are parallel but do not converge. So for example, the little corners of these beams right here, these rails, the edges of these little cupboards and so on. Really, the stuff becomes really intuitive the more that you do it. And so if you're feeling overwhelmed for now, know that these rules do not change, but your brain does, because your brain will constantly adapt and mold to new material. That means that this stuff will become easier and easier the more that you practice. So let's take a look at how to extract perspective from a photo ref. There are two stages to doing that, and the purpose of this is just to set up your camera location. All right, so let's see if you understand this. Step one is I want you to find the vanishing point using 3 or more lines of convergence. You can do it with 2, but sometimes there's a little distortion with the camera lens, and your lines might not always line up perfect. So that's why you usually want to go with, say, 3. If you want more practice, just use more. Once you find that vanishing point, then I want you to define the horizon line. So a couple of ways you can go about it is we've got this ceiling corner right here. We've also got the edge of the table, and we've also got the bottom edge of the countertop. This house is very nice and neat and orderly. Everything is lined up perfectly at 90-degree angles. We've got this side of the countertop, we've got the left side of the counter, and we've got the ground side of the counter. And sure enough, they converge again at the same point. Let's go forward again. We've got the edge of the rug. That's parallel to this appliance up here in the kitchen. And that is parallel to the direction that all this wood grain is going. The wood grain I did because sometimes some images aren't exactly very easy to find edges. And so you kind of have to look for clues in the image that give you convergence points. And sure enough, if this is our VP, then this is our horizon line. So a good exercise to do when you come to class is I've got an image pool that's shared on the Google folder with you guys. What I want you to do is with your Chromebook, enlarge that image so that it fills the screen of your Chromebook. Then with a sheet of plastic and a dry erase marker, place the plastic over the monitor of your Chromebook and then extract the perspective information, just like I did with those photos, using that erasable marker. In class, show it to me and I'll assess it to make sure that you have an understanding or not. Thank you for watching, and in our next video we will use this information to build structures in perspective. Have a good one.